Hey guys, and today I'm going to review density and introduce us to some density practice problems, and hopefully we'll be able to dissect answering density-based questions, as basically when you're dealing with density, you're mainly focusing on three variables. So let's go ahead and look at the concept of density itself. It's basically a measure of how much a mass is packed within a specific volume. Uh, the tendency is that substances that feature a higher density, like that of steel, have molecules that are kind of packed tightly together within a specific volume. Conversely, substances that feature low density, like quark, tend to have less molecules and they're packed within maybe a similar space. And so when you're talking about density, you're looking at the packing of these molecules. Now, the density itself of a substance can be found by dividing the mass by the volume. Mass can be indicated using grams, kilograms, pounds, etc., whereas volume can be measured by milliliters, liters, or even cubic centimeters if you have a object or an object that features a three-dimensional arrangement that can actually be solved from geometric deductions. So that's kind of how that works. Now, in order to solve for the density, the substance has to be homogeneous. This means that the sample is the same throughout. There's no variation in the type of matter that is used to make up the compound or substance particularly. So essentially this would mean that if you're able to identify the density of a steel paper clip, it would be comparable to finding the density of a steel girder, which is used to build a bridge. Now, when we talk about the equation of density, density is generally represented by the general expression density being equal to mass divided by volume. Rewritten, it could be D is equal to M over V. Now, by extension, algebraic manipulation would suggest that if we were solving for M would actually be equal to D times V. So that's density times volume to equal your mass. And if you were looking at your volume is equal to your mass divided by your density. Now, in some circles, the manipulation and understanding of the relationship between density, mass, and volume can be represented by using by this triangular structure. It's become more popular when you have three-pronged or three-variable manipulation-based problems. And when you're looking at it, depending on the unit that you're solving for, you can apply this diagram organizer, if you will. So if you're solving for density, you would get density by dividing mass over volume, whereas if you were solving for volume, you would divide mass over density. Now, if you were solving for just mass by itself, you would get that by multiplying density times volume. And so this graphical organizer represents an extension of kind of what I just stated with these, with a lesser degree of, I guess, algebraic manipulation being required. So it is an alternative. Obviously, I'm more of the old school sort where I've just kind of mastered these, but this is also a method in which the actual solving of density-based problems can be used. All right, so let's go ahead and solve some problems, shall we? All right, we're going to use the density formula, and we're going to try to show our work, and we'll try to solve these problems. Now, the first one about this refers to a block of ice with a volume of 3 cubic centimeters, and it would have 3 milliliters of liquid after being melted. And that brings up a very fair assessment that needs to be known about water. One, water density is 1 gram per milliliter. That is the density of water. Also, it needs to be known that 1 milliliter of water is going to be equal to 1 cubic centimeter of water. Now going forward, we're going to go ahead and get started, but this may come up later. So we want to keep that in mind, that 1 cubic centimeter being equal to 1 milliliter relationship. And since water's density is 1 gram per milliliter, it's almost like all of the other densities are being used to compare to, with water being kind of the basis or the foundation, if you will, of where density is deduced. And then oftentimes when you're comparing density, if the density value is less than 1, it tends to float in the liquid. And when it's heavier than 1, you see a tendency of the object in question sinking in the water. So let's go ahead and look at this first one. What's the density of carbon monoxide gas if 0.196 gram occupies a volume of 100 milliliters? Simply stated, this is our mass here. It's in grams. This is our volume here. And so we're going to solve by using the blanket arrangement. So 0.196 grams over 100 milliliters. So 0.196 divided by 100, and that's going to yield a value of this, which is 0.00196. That's grams per milliliter. All right. All right, let's look at another one because that was kind of straightforward. So we have a block of wood that has 3 centimeters on each side and has a mass of 27 grams. What is the density of the block? So we need to think about this block as a three-dimensional object. Now please excuse my drawing because I am no artist. I am terrible at drawing three-dimensional objects. It's not my expertise. So again, bear with me. So that was supposed to be a block. Obviously, I did a terrible job at it, and I acknowledge that. I accept that. My gift is in doing chemistry problems and not drawing blocks. That being said, we're assuming that the block has 3 centimeters on each side. So 3 centimeters here, 3 centimeters here, and 3 centimeters here. And so if you're trying to look at it from this point, we're going to be looking at a three-dimensional object. And the volume is going to be represented using cubic centimeters. Now, this is our mass. This is going to help us solve for our volume. If we know that a three-dimensional object has 3 centimeters for its length, it has 3 centimeters for its width, and it has 3 centimeters for its height, we can multiply all of those together to get a total of 27 centimeters cubed. So 3 times 3 is 9. 9 times 3 is 27. And when we multiply each one, we're increasing the exponent for the centimeters. So centimeters times centimeters squared. Centimeters squared times centimeters, because there's 3 of them, ends up cubed. So this number represents our volume, our V. We also have our mass, which is 27, and so we're going to apply this arrangement where we have our mass over our volume. That said, 27 grams divided by 27 cubic centimeters is going to be used to solve for our density. Now, I don't need a calculator to see that 27 grams divided by 27 cubic centimeters is going to be equal to 1 gram over 1 cubic centimeter. And that's our answer. So very straightforward. The only difference here is the volume is represented by cubic centimeters, and we have to ascertain the volume using geometry. Now let's look at some other questions. And number 3, there's an irregularly shaped stone that was lowered into a graduated cylinder holding a volume of water equal to 2 milliliters. The height of the water rose to 7 milliliters. If the mass of the stone was 25 grams, what was its density? So it being irregular means that we can't find the three-dimensional representation of that object. And here I'm going to do my best drawing of this process. This is water. I got the rock. It was at that height. It rose when you added the rock. So it rose. And we're saying that it rose from 2 milliliters to 7 milliliters when you added the rock. Alright, so what I'm going to look at for solving this is I know my mass is 25 grams. This is my mass. I can't tell you what my volume is unless I subtract what the volume was at the end from the volume initially. So 7 milliliters minus 2 milliliters tells me the volume of space that that irregularly shaped stone covers, which is 5 milliliters. And that's my volume. I know my mass, I know my volume. I can solve for density because density is equal to mass over volume. In this case, 25 grams is going to be divided by my 5 milliliters. That's going to give me a density of 5 grams per milliliter. Alright, so let's look at another one. Here we have a 10 cubic centimeter sample of copper that has a mass of 89.6 grams. We're tasked with finding the density. We know that density is equal to mass over volume. This is our volume. This is our mass. We're just going to compare those two just like we've done before. 89.6 grams. And we're going to divide that by 10 cubic centimeters. And when we solve, we end up with 8.96 grams cubic centimeter. So when solving these, a huge portion of being able to solve it starts with just being able to identify what units are being given. Alright, so let's jazz it up a little bit here. We're going to look at number 5. Silver actually has a density of 10.5 grams, is what they're saying here. Put a D. And gold has a density of 19.3. So density there. Which would have the greater mass? 5 cubic centimeters of silver or 5 cubic centimeters of gold? Alright, so let's look at this question, shall we? We're given the density for each, and we're given the volume. So we're being asked to solve for mass. Now, if you recall from, I guess for some people, the triangle would look like this, where you have your D and your M and your V. And that would dictate that if we're solving for our mass, we're going to be multiplying our density times our volume to find our answer. Alright, so let's look at that. For gold, we have 19.3 grams per cubic centimeter, and that's being multiplied by 5 cubic centimeters. And we have our silver, which has a lower density. It's a little bit lower. It's 10.5 grams per cubic centimeter, and we're going to multiply that one by 5. Now, I don't know if the math is required. Looking at it, I can tell you that the gold is going to have a greater number, but I see no harm in actually showing the math. So in this case, the mass is going to equate to 96.5 grams for gold. And if we're looking at that for the silver, it's going to be 52.5 grams. And comparatively, your gold is almost going to be double the weight of silver based on its density. Okay? All right, so let's look at one more. Well, maybe two more. Might have time. All right, so I have 5 mils of ethanol. Yeah, they tried to put that on there. That's a liquid volume. 5 mils of ethanol has a mass of 3.9 grams, and 5 mils of benzene has a mass of 44 grams. Which liquid is denser? So to compare these, we are going to have to compare their densities. D is equal to M over V. This is a volume. This is a mass. This is a volume. This is a mass. We're going to compare ethanol by dividing 3.9 grams of that over 5 milliliters. We're going to compare benzene by comparing the 44 grams to 5 mils. Now, even without solving, I can see that the benzene is perhaps going to have a greater density. And so because its density is greater, it's probably going to be a little bit more dense. But let's go ahead and solve it nonetheless. 3.9 divided by 5 yields 0.78. And 44 divided by 5 yields 8.8. This is grams per milliliter. This is grams per milliliter. If I was comparing these, I would say that benzene has the greater density and therefore would be more dense. And comparatively, if you put benzene in water and you compare that to ethanol, I think the ethanol, if it was possible and it wasn't already mixing and becoming miscible, it would actually float if it was a solid object, and if benzene was a solid object, it would probably sink to the bottom if that were our density value. Seems like a very high density value for benzene in my opinion, but nonetheless, it's all good. So let's look at this last one. We have a sample of iron that has dimensions of 2 by 3 by 2. If the mass of this rectangular shaped object is 94 grams, what is the density of iron? So it's given us the three-dimensional arrangement of the object. I'm going to simply multiply those because those are going to give me my volume. And then the 94 grams is going to give me my mass. So 2 times 3 times 2, that's going to yield 12 cubic centimeters. So if my mass is 94 grams, I'm dividing that by 12 cubic centimeters. And I'm going to proceed with solving. Remember, we are doing density is equal to mass over volume. Now, when we have 94, we divide that by 12. Our answer ends up being 7.83, and that's grams per cubic centimeter for iron. Now, that completes our instructions on density calculations. We've looked at the arrangement of density. Hopefully, we've been able to diagnose when to use density problems, and we understand that it starts with identifying the variables in question, whether it be mass, the volume, or the density. One of the tells in general is usually the units being associated. For volume, for instance, you're either going to see your centimeter reference, or perhaps you'll see milliliters. For mass, you'll see grams in isolated fashion. When you're talking about your density, you'll see that comparison of your grams per milliliter. And so units are so very vital when solving these problems.